Now, after understanding the concept of the law of conservation of energy, now we can look into details and do the calculations to see how we can make use of the concept of the law of conservation of energy to calculate the final temperature. So what we have here is two different sections. And for this type of calculations, it is highly recommended that you break the steps down into as many as possible, so that you can always go back and check yourself to see where you make a mistake, if there's any. So let's look at the heat energy gained by the water. So we understand that the water is going to heat up. So there will be a temperature change. And from the question, we don't see any signs or any statements that indicates a change of state. So we will assume that there will only be a change of temperature, and the final temperature, we will not know what the final temperature is until the very last moment of the question. So what we will do is to use Q, and in this case it will be Q1. And since it is just a change of temperature, we will use the equation mc delta T. Now, most of the information should be given by the question, or it should be memorized, or it should be given right on top of the paper, like the given information. So the mass of the water is 500 grams. The specific heat capacity for water is 4.184 joules over grams times a degree Celsius. And the temperature, which is the change of temperature, which is always the final minus the initial, it is TF minus 20.0 degrees Celsius. In this case, I'm going to use T subscript F to stand for to represent the final temperature. Now, this is just a unknown. If you feel more comfortable with the X, feel free to use X. But here, I'm going to make it clear that it is a temperature, and it is the final temperature, and this is why I'm going to use T with the subscript F. Okay. Now, we can do a little bit of simplification here. So 500 grams times 4.184 joules per grams times degrees Celsius. So we can multiply this two and get 2092 joules over degrees Celsius. Okay, and the unit is slightly different from here because the grams are cancel out. Okay, and we are going to leave it like this because we are not going to solve for the. We cannot find out what TF is at this stage. We will find out what the final temperature is when we finish this part and we make use of the equation that we mentioned in the previous tutorial. Okay? So let's look at the heat energy lost by the copper block. And now the copper block is a solid. And when it is put into the water, it is still a solid. And the only thing is changing is a change of temperature. So we are going to use the same equation since it is just a change in the temperature. Okay? Now, the question gives you the mass of the copper block, which is 200 grams. And the specific heat for the copper is 0.385 joules grams times degrees Celsius. And again, the delta temperature, the change of temperature is equal to final minus the initial, and in this case the initial is 105 degrees Celsius. And let's do a little bit of the simplification on this side. So 200 times 0.385, it is equal to 7 77 joules per degree Celsius. And then final temperature minus 105 degrees Celsius. Now, we have identified the heat energy gained by the water, which is here, Q1, and also the heat energy lost by the copper block, the Q2. So what we need to do right now is to make use of the equation that we defined in the last tutorial, which is the heat gained is equal to the negative of the heat lost. And when we put it there, that should give us the answer. And we will take a look on that calculations in the next section of the tutorial.